This is the video, Lewis structures of covalent molecules. By the end of the video, you should be able to write the Lewis structures of covalent molecules. When viewing this video, you should have your pencil and the Lewis structure of covalent molecules video sheet. First off, what is a covalent molecule? Covalent molecules are formed by non-metals only, which we had last semester. It is going to create a bond that is formed by the overlapping orbitals between atoms and is caused by sharing the electrons between the molecules, or between the atoms. Remember in ionic, electrons were transferred, now they're going to be shared. The rules are, first, determine how many valence electrons you have. Second, determine which atom to put in the center. When doing so, find the atom that has as close to 4 electrons as possible. Next, add your bonds. When doing this, be sure to follow the octet rule, where every atom will end up with 8 valence electrons, and make sure all the valence electrons have been used. Our first example, OF2. To do this, you want to start with how many valence electrons does it have? Oxygen has 6 valence electrons. Each fluorine atom, and there's 2 of them, has 7. This is going to give you 20 total valence electrons. Now, the center atom is going to be oxygen, because oxygen has 6 valence electrons. Fluorine has 7, so oxygen with 6 is the closest to 4. We're going to put the fluorines around them, and we're going to use lines to represent the bond. So the line is going to represent a bond, and each bond is going to have 2 valence electrons in it. So right now, since we've used up 2 bonds, and they have 2 valence electrons apiece, we have used up 4 valence electrons, which means we have 16 left. We now need to follow the octet rule. Every atom should get 8 valence electrons total. This fluorine has 1 bond, or 2 valence electrons. It needs 6 more. So we're going to put the 6 electrons around it, similar to what we did with our Lewis dot structures for atoms, 2 per side. So we've just used up 6 more electrons. We have 10 more to go. This fluorine also has 1 bond with 2 valence electrons. It also needs 6 more. So we're going to put those around it and subtract out those 6 electrons we just used, which leaves us with 4. Oxygen has 2 bonds. Each has 2 electrons, so we've used up 4. In order to get to our octet, our 8, we need to use 4 more, which is exactly what we have. So we're going to put those down, and when you subtract it out, you have 0 valence electrons left. Let's double check our structure to make sure it's good. First, we need to use 20 valence electrons. We have 4 in the bonds, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we now have our 20 valence electrons. 4 are bonded electrons, or shared electrons, and 16 are unbonded or unshared electrons. Okay, let's try NBr3. Nitrogen, according to your periodic table, has 5 valence electrons. We have 3 bromine atoms. Each one has 7 valence electrons. 21 plus 5, we have 26 valence electrons to use total. Nitrogen is going to go in the middle because it has 5 valence electrons. The bromines will go on the outside. In this case, we have 1, 2, 3 bonds being used, or 6 valence electrons, which means we have 20 left. Bromine has 2 valence electrons being used. It needs 6 more. And each bromine is going to need 6 more in order to be an octet. So we've just added 6 plus 6 plus 6 more, or 18 electrons. It means we have 2 more to go. Now the nitrogen in the center already has 1, 2, 3 bonds, or 6 electrons. It needs 2 more to have an octet. So we're going to put a pair there to finish the octet. Now let's double check to make sure we have 26 valence electrons. 1, 2, 3 bonds times 2 is 6. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. We have used over 26 valence electrons. That's good. Now let's make sure everybody has an octet. Bromine has 2 in the bond, 3, 4, 5, 6, 7, 8. It has an octet. Both bromines here are the same. Nitrogen in the middle has 1, 2, 3 bonds, or 6 electrons, 7, 8. It also has an octet. Now, yes, these electrons count for bromine's octet and nitrogen's, and that's because it's being shared. There are some exceptions to the octet rule where you can end up with less than 8. The first one is atoms in group 1 will end up with only 2 valence electrons when they're done. And the biggest example of this is hydrogen. But if you remember, hydrogen is a nonmetal. The rest of the things in group 1 are metals and probably will not be found in a covalent molecule. Atoms in group 2 will end up with 4 valence electrons. This is not very likely to happen in covalent molecules because covalent molecules usually have nonmetals only. Group 13, and the biggest example of this would be boron, will end up with 6 valence electrons. Let's try some examples of this. First off, CH4. Carbon, determining the number of valence electrons, has 4. There are 4 hydrogens, each one has 1 electron. So we're going to have 8 valence electrons total. Next, center atom, carbon goes in the middle because he has 4. Now, all the hydrogens together have 4, but individually, each hydrogen only has 1. So hydrogen does not go in the middle. We're going to go ahead and put the 4 hydrogens on the outside. Now we've used up 1, 2, 3, 4 bonds. Each bond has 2 electrons. So we have now used up all of our valence electrons. Let's make sure everybody has an octet. Carbon in the center has 1, 2, 3, 4 bonds times by 2, or 8 electrons. Carbon has an octet. That's good. Hydrogen has 1 bond, 2 electrons, and nothing on the outside. No unshared electrons. So hydrogen has 2 valence electrons. But as a member of group 1, that's enough to make him happy. You're going to find that each hydrogen will always make 1 bond, and that's it. Let's try one more exception. Boron trichloride. Boron has 3 valence electrons. There are 3 chlorines, each one has 7. So 21 plus 3 is 24. Center atom is going to be boron, because boron with 3 is the closest to 4. The chlorines will go around the outside. Right now we have 1, 2, 3 bonds. Each bond has 6 electrons. So 24 minus 6, we have 18 valence electrons to go. Now chlorine here has 1 bond and 2 valence electrons. It needs 6 more to be an octet. Each chlorine is in the same situation with 1 bond and 2 electrons, and therefore it needs 6 unshared electron pairs in order to be an octet. So let's go ahead and put those in. So we have just added 6 plus 6 plus 6 unshared electrons. That uses up all of our valence electrons. But let's see that everybody has an octet. This chlorine has 2 shared electrons plus 6 unshared. It has 8 total valence electrons. It has an octet. Each of these chlorines look exactly the same and also have an octet. Boron in the center, though, has 1, 2, 3 bonds. Each bond has 2 electrons. It has 6. But as a member of group 13, that satisfies his rule, and he is stable with just 6.